Assalamualaikum dan selamat pagi. Apa khabar semua? Hari ni kita nak buat lab untuk matlab dan simulink. Jadi saya memikirkan saya perlunya buat video supaya kamu boleh ulang, boleh tengok banyak kali, boleh ulang dan ulang video tu. Okay? Jadi pertama sekali apabila kamu sampai ke lab komputer, saya harap kamu dah sampai sekarang. Kamu buka PC masing-masing. Ada PC yang ada matlab, ada yang tak ada. Cara nak tengok ialah kamu tengok simbol matlab lah. Simbol ni. Okay. Kamu tengok simbol ni. Okay. Kalau yang dah buka tu dah bersedia, boleh tekan lah. Okay. Saya pun buka kat sini. Okay. Kamu perlu tunggu sebab ianya bergantung kepada kelajuan laptop masing-masing lah. Kalau laju, lajulah. Okay. Okay, jadi here we have matlab. Okay. This is matlab. We call it a window for the matlab. We have a command window here. We have a home button with a lot of this button. Don't worry. There's a few that we're going to use in this session. We also have a plot and apps. This is a new feature. Last time during I learned MATLAB, there is no this two thing. Okay. Just this home button. Okay. And then on your left side, we can see a current folder, which is a file directory. And this window might be a little bit different from yours because I have my MATLAB for 2015, and at that lab computer I think it's 2018, right, or 2017. But don't worry. Okay. For the lab number 6, what you're going to do is you're going to use this MATLAB, which is this command window, to solve mathematics. Okay, you can refer to your lab module. Okay. Okay, I have lab 6 module here, whereby if I can see that if you really read this lab module, you can do this MATLAB. Okay, and but this one is MATLAB for 2008 or before that. Okay, so it's the desktop is quite different from yours, but don't worry, you're going to use more of on the common window. Okay, so what you have to do is you need to go down until the last page of this lab module, which is the task of the day. Okay, you have this mathematical equation, so you're going to solve this mathematical equation using MATLAB. Okay, so you're going to solve it using MATLAB. This common window work like your calculator. For example, if you have 4 plus 4, you get 8. Okay, same goes if you want to write something like 2 times 3 equal to 6. Okay, just the operation itself. Okay, the language of the MATLAB, the symbol, make sure you are using the correct symbol. Okay, plus, minus. Okay, plus. Okay, you have a plus, minus, and then you have times and divided, and all other operation should be in the correct, otherwise you get some error. Okay, for example, if I want to use a multiply operation, it should be this symbol. Okay, not this symbol. Okay, not this one, because when we press enter, it will be a undefined variable, because MATLAB detect it as a variable. Okay, so you have to solve all the equation, all this equation in MATLAB. Okay, and if you don't know how, you have to refer to the previous page. Okay, it shows you how to do the metric, how to do the multiple square root equation and all and whatnot. Okay, so you have to try it. Okay, so moving on into, okay, if you want to delete everything, if you want to clean out your common window, you just type CLC and everything will be clear for you. Okay, that is for the lab number 6. Okay, so moving on to the lab number 7. Okay, the lab number 7, whereby in a MATLAB there are another software that actually I'm using it for generating your response, which is your graph from your experiment, the graph that have been, you have done your lab report using that graph. That graph is generated from this software. Okay, this is a simulink software. It is integrated inside MATLAB. And then for this simulink software, what you have to do is, again, you have to solve the task of the day. Okay, all the tasks, you have to submit this task. Okay, so we show you how to start with, and later on you can go to you can try by yourself. Okay, so here from the desktop of the MATLAB, you can see this symbol, which is a simulink library. Okay, this simulink library, you just press once again and you wait for it to open. You can see here, okay, it's starting. It took some time. You have to be patient, and you have to be more patient if your laptop is very slow. Okay, and what you have here, the pop-up will come out, which is a simulink library browser, which is all the block. Okay, is here. What you have to do is you press this button. This is a new model. Okay, it shows us a new model. Okay, click that, and this white, another pop-up will come out. This white page with untitled, because we haven't given any title yet. Okay, so you can refer to your lab module. Okay, I'm not referring here because I already know what to do. Okay, we start with a process. Okay, we have a process which represent by a transfer function. That's why you learn transfer function at the first place. A transfer function is a dynamic model that represent a process in a S domain. Okay, later on I will make that another video, answer all your equation. Okay, all your equation. I'm sorry. Okay, so you can type FCN, which is a transfer function. Okay, just press enter. Oh, no, not press enter. You have to push this button. Click this button. Okay, you can see this. This is a transfer function. Okay, so we have a process that represented by this transfer function. This is first order transfer function, and then from a process we're going to give a input. Okay, you have learned a lot of input, type of input. There are step input, ramp input, sinusoidal, and whatnot, but here we just use a step input. You can just search for step. Okay, again click this button. You can see here there are this block that represent a step input. Okay, and then you have a process, you have a input. Okay, okay, I rename it for you. Okay, later on. Okay, before that, what we another thing that we need to do is we want to see the response. In order for us to see the response, we have to put it in a scope. Okay, meaning to say we can find at this category, at sync category, which is a scope. Okay, so we connect. Okay, just drag everything to connect each other block. Okay, and then I will rename it for you. Okay, you can rename the block. Okay, so here we have a process. Okay, you have a step input. Okay, you have a step input, you have a process, and you have a response. Remember, you have learned about step input, different type of input, and you also have different type of response. Okay, so once you get this kind of block diagram, what you need to do is you have to press this button. This button is a run button. Okay, don't run away. It's actually for the simulation to run to solve the equation. Okay, so just click this button. Okay, and you just wait until 100%, then it's already solved for you. And then double click at the response, you can see the graph. Okay, so this is a graph of response, or this is a step response. Okay, this graph is a step response for the first order process. Okay, if you have a second order process, you have different graph. Okay, so this is how we simulate a process. Okay, later on when you learn in a class, okay, or you will learn through my video, you will learn about a different process, and we integrate everything into a feedback loop. Okay, that is a lab number 8. Okay, if you have any question, you can ask me later through a Google Meet. Okay, I will just stand by for you. Okay, so this is how to do a simple lab 7, which is a simulink, introduction to a simulink, whereby you have a process, you have an input, and you have a response. Okay, how about if you have a, you want it, you want a second order, you don't want it, of course. You want a second order process, you just double click on this button. Okay, this pop up will come out, and then you have to add another parameter, maybe here, maybe here. Okay, and then you will have a second order transfer function. Once you get that, again press a run button, but don't run away, just wait there. And then once it's completed, you just double click on the response. You can see the graph is slightly different. Okay, if you want to compare a lot of graph, a lot of transfer function, you just select everything, press Ctrl C, and paste it by Ctrl V. You have another set of uh, block diagram, and we can compare. Why not we do that? Okay, because I really love this software. Okay, so we have first order and we have second order. Okay, I can name for you first order process and second order process. Second order process. Okay, and then you will have a two response graph. Okay, how to compare that response graph? Uh, the method is we have to find another graph. We have to plot another graph. Okay, just drag another scope, and we have to put another operation. Okay, it is called MUX. This, drag it here, connect all the arrow. Okay, this one to this one. Okay, and click run again. Okay, close this one first. Okay, this is a response for first order. Okay, you can see like this. This is a response for second order. Okay, it's slightly different. Okay, and for the comparison graph, just click this graph, this scope, and we can see the difference between these two graphs. Okay, for the second order response, you will learn about, you have learned actually about the overdam, underdam, or overshoot. Okay, and you can just try and play around with all this value of transfer function, and it will give you different response. Okay, okay, that's all for lab 7. Very easy. Okay, don't forget to save this your simulink file. Just save it somewhere. Okay, I just okay. Okay, just save it at any place that you want. Okay, I will put it here, and then put it as lab 7 maybe. Okay, just save it. So if you have been asking for this, you just say yes. Okay, no problem. Okay, okay, so you get this lab 7. Okay, so why don't we move to lab number 8? You can pause this video if you need a break. Okay. Okay. So again, let's see what is your lab 8 all about. Okay. It is a PID tuning. Okay. This PID tuning, like I have been told, not all of you, some of you that came to see me last time, asking me about lab uh, pH or temperature. This is all about that lab is about PID tuning. Okay, this tuning is, in a simple word, tuning is you want to find the best value of Kc, tau I, and tau D. Meaning to say, you want to find the best value of PID setting, the best value of PID setting, so that the response that you get is uh, the best response. The characteristic of the response you have learned in terms of rise time, settling time, overshoot. Okay, that is a characteristic of a response for you to define, for us to define whether that response is a good or not. Okay, so last time when you try to do a pH and temperature experiment, that two experiment it also cover about PID tuning. But the difference is you have a machine there. We have a machine, a pH machine. Okay, and then temperature, which is a heat exchanger. That machine are there at the lab. But here we have a software. And then we have a process that represented by this transfer function. So it's applied the same method, which is PID tuning. What is the best value for Kc, the best value of tau I, and the best value of tau D. That is the purpose of this step. Okay, the difference is you have a physical machine, and here we have a software. Okay, so what you need to do is you're going to use a simulink to construct a closed loop diagram. Okay, we go back to a simulink, we go back to a matlab and simulink everything. We can just close it. If you already done, you can close it. Make sure you save it. Okay, make sure you save your lab 7. Okay, because later on when you want to do your lab report, you have to put this diagram together with all the graph. Okay, okay, I can close this one. Okay, so we go back to the simulink library. This one, we're going to start a new model. Okay, to start a new model, okay, just press this button, or this one is here. Okay, this one. Okay, what we have here, again, we start with a process, which is we have a transfer function. Okay, we have a transfer function. Just search for the transfer function. This is the fastest way for you to get to the block. Okay, you can go one by one, clicking this, and it took you some time. Okay, why don't you just go directly? Okay, and then the new thing here is you need a controller. Of course, to do a PID tuning, you need a controller, which is a PID. So just search for PID. Okay, search for PID. It will come out like this. Make sure you choose a correct PID block. Okay, don't use discrete or other. Okay, just use this one PID. Make sure it is a correct block. Okay, and then because of your transfer function is a third order, okay, you have to do third. You have to replicate this block. Okay, you can just copy and paste this block. Okay, okay, and then remember your response. You need a response. Okay, you have to go to the sync, whereby you can see a response here, and then you also need a source, which is an input. Okay, the source you can find here, which is a step input. Okay, and then you have you need another operation, which is can go to the operation for commonly used block, if I'm not mistaken. Okay, not here. Universe, maybe not. Okay, like I told you, it takes some time. Okay, go to the mat operation. When you are here, you just need can use this one. Add. Okay. So for this one, remember your PID, your feedback loop, it should be plus and minus. Okay. Then connect all the block, the step to the plus symbol, then connect everything. Okay. Okay. And this one you have right backward. Okay. So that you have a feedback loop, which is this line. Okay. You can just directly press run, spawn, something like this. Okay. So to do a tuning, what you have to get is, okay, we'll go back to the app. You have to get a sustained oscillation. Okay, just like you have been given a graph for temperature and pH, that sustained oscillation graph. Okay, you have to get that graph. Okay, so go back. So you didn't get the sustain yet. For that, what you need to do, you have to increase the the time for the simulation. Okay, instead of just 10 seconds, we increase to 100 seconds. Okay, then we try to run it again, and then you will get this kind of graph. Okay, get this graph. I just want to matlab as a background. I don't want you to get confused. Okay, you will get this kind of graph. In order to do a tuning, what you have to do is you have to double click this, and you change the value of P, I, and D. Just change accordingly until you get a sustained oscillation. Okay, so for this time being, I will try to reduce it. to 0.8. Okay, just see what happened. Okay, that is what happened. Still get still doesn't show any different. Before I forget, uh, the others should be 0. In order for you to obtain a sustained oscillation, you just change the value of Kc. The value of Kc here represented by the value of P. Okay, okay. Try again. We have to eliminate the effect of I. Okay, we get this. So in order, and another important thing is this transfer function is my transfer function. It's not the same with your. It is not the same with your lab 8. Make sure you use a query. Okay, I don't want to show you everything. I want you to try. Then just keep on manipulate the value of PB or the value of P. Okay, you can increase or you can decrease until you get a response of a sustained oscillation. Okay, I still didn't get it here. Okay, I might need to increase further. Okay, we increase further, we can see the response start to oscillate, but it is not yet sustained oscillation. Okay, you have to keep on trying. Okay, until you get a sustained oscillation. Okay, so have a try first. Okay, you can just try to play around with the value of P. Okay, you have to increase further. I want to increase until 8. This is based on my transfer function. It's different from yours. Okay, just play around until you get a sustained oscillation. Okay, something like this. Until you get a sustained oscillation. Once you get a sustained oscillation, you have to use a Ziegler-Nichols tuning rules, whereby from the value of AC you can find the value of PB. You can determine from a sustained oscillation, you can determine the value of ultimate period TU, or in your lab module it is a TN, and later on you can find the value of PB, value of KC, tau I and tau D using that formula. It's not written here, but you can find it is the same formula from your lab report. Okay, you can use that formula. The same method that you are doing your the same method as you do your lab pH and temperature, and then once you get this sustained oscillation, once you get the value of PB, tau I and tau D, you substitute again in this PB tau, substitute again here, and then you should get this graph. Okay, you should get this graph. Okay, if you don't get this graph, you have to go back to do again the tuning. Okay, so that's all for this video. Hope it helped you to do this 3 lab using MATLAB. Okay.